A square pyramid is positioned using a coordinate system so that ABCD is a square. You can see all this in the diagram, with point E the vertex of the pyramid. The origin O is the midpoint of DB, so it's the middle of the square basically. The position vectors for A, B and E are denoted respectively by A, B and E. Again, you can see that in the diagram. Point F is the midpoint of the edge AB, and M is the midpoint of EF. In terms of vectors A, B and E, determine the simplified expression for FE. So we want to go from F to E. So we can do that by going from F to O and then going from O to E. So if we think about going out like this, that would be a diagonal of a new square that we've formed there. And going from O to this point over here, which I'll call X for now, that would be A plus B. So going from O to F is a half of A plus B. So going from F to O is negative a half of A plus B. And then we just do E. So that's that one done. We now want to do DM. Now I can do that as DO plus OF plus FM. So let's look at the diagram there. I'll work up here so we can see the diagram at the same time. Now DO is just going to be B. OF is, as we discussed here, that's going to be a half A plus B. And then F to M is 1/2 of FE, which is what we got as the answer to A part 1. So what we have there is B plus a half. Let's split that up. So we've got a half A plus a half B. Take away a quarter A. Take away a quarter B plus a half E. The stuff on this last line here is just half of our answer there. So that is going to be 3 over 2b by adding this one and this one, but we've still got to take away a quarter of b from that. And then we've got half of a take away a quarter of a. So that one is a quarter of a. And we've got the half e. And then this is 6 over 4, take away 1 over 4, so 5 over 4b plus 1/4 a plus a half e. Now, determine the expression for dm.fe in the form x mod a squared plus y mod e squared, where x and y are real constants. Now, let's do dm.fe. But think about this. Because we know the base is a square, a and b are perpendicular. A and b are both perpendicular to e as well. So we know that a dot b is equal to a dot e is equal to b dot e is equal to 0. Because it's a square, we also know that mod b squared is equal to mod a squared. They're the same length. So what we have is 5 over 4b plus a quarter a plus a half e dot negative a half a take a half b plus e. Expanding all of that out gives us negative 5/8 b dot a. Take away 5/8 b dot b plus 5 over 4 b dot e. Take away 1/8 a dot a. Take away 1/8 a dot b plus a quarter a dot e take away a quarter a dot e, take away a quarter b dot e, and plus a half e dot e. And that's just expanding, just using a sort of crab claw type method for all three terms. Now let's look at all the ones that are actually 0 here. B dot A, B dot E, A dot B, A dot E. Got another A dot E here and a B dot E. So what are we left with? We have got negative 5/8 of B dot B, which is mod B squared. Take away 1/8 of mod A squared plus a half of mod E squared. And since we know that mod B squared is mod A squared, we have negative 6/8 of mod A squared plus a half mod E squared, which is negative 3/4 mod A squared plus a half mod E squared. If angle DMF is to be a right angle, then determine the exact value for mod E over mod A. So DMF, well, this dot product would do that. So DMF, and that's the, so we've got DM here. We've got, that's in the direction of FE, FM. And so if that's going to be a right angle, then the dot product would be 0. So negative 3/4 mod A squared plus a half mod E squared is equal to 0. So we get a half mod E squared is 3/4 mod A squared. Mod E squared then would be 3 over 2 mod A squared. So mod E squared over mod A squared is 3 on 2. So mod E divided by mod A is root 3 over root 2, and rationalizing the denominator gives us root 6 on 2.